Textbooks open, page 512. You did numbers 34 to 44, the even. So whatever that was, about 6 problems or so. It's not a real long homework assignment. We're practicing reducing radicals, making them smaller, making them simpler. And the key to reducing radicals is to do what to the radicand, class? I said that already. How? What do I do? Factor. Okay, what's the key, class? Factor. But specifically, if it's a square root, you want to factor it so that one of the factors, for instance, is a 4 or maybe a
36,
49, so forth. 100 might be a good one to watch for as well. Remember, anytime it ends in 00, the 100's going to go. If it ends in 25, 50, 75, 25 will work. What's the rule on 9 again, Glenn? You know a 9 is a factor if... Evie?
When the sum of the numbers digits is divisible by 9.
Ah, you read that off the poster well. If the sum of the digits is, and now Glenn's like, oh, I could have done that. Yeah, he didn't notice the poster. Sum of the digits is divisible by 9. And what about the rule for 4? Back to Glenn now that he knows the poster's up there. Last 2 digits are divisible by a 4. Then the 4 is going to work. But if it's a cube root, none of these work. None of these help. If it's a cube root, class, we're looking for numbers like 8,
27, 64, 125.
Okay, all of these, the cubes that we've seen so often. Again, if it does, 5 or 10 kind of ending there. If it's got a 3 in it, maybe the 27 works. Oftentimes, it's got to be even for one of these to work. But anyway, so figuring out, right? Trial and error in some cases, figuring out which factors specifically we need. Number 34, we have the square root of a 68. How did you factor the square root of 68? Aubrey? Yeah, I mean, you're looking down the lineup, and my first thought is, well, try cutting it in half. That's a 34. That doesn't help, because 34 isn't one of the numbers, which means, by the way, 36 isn't going to work. I know 25 is going to work. Maybe 16, 9, 4. It ends up being a 4 times, you said, 17. So your answer is 2 times the square root of 17. How many have that answer as well for number 34?
For some reason, I flipped it. I put the 2 inside. I don't know what I was doing, but it had the numbers. I just transferred it.
Yeah, remember, take the root of, so again, another way to think of this, Danielle, and I don't normally take the time to show the split. We showed it in the first lesson, and then I said, well, I don't usually do it because I'm lazy. But if you'll take the time to split it into square root of 4 and square root of 17, which of these is working out evenly? The square root of 4 is working out to a 2, and the square root of 17 just stays as is because you can't do nothing with it. Looking at number 36, we have the square root of 243. Hayden, what did you do with this one?
9 and 17.
I don't think it's a 9 and 17. 9 does go in, though, right? The sum of the digits adds up to 9, so I know there's a 9 in it. 9 goes into 24, though.
Oh,
Twice with...
6
and then 9 goes into 6. So you're right about the 7, but a 27, not a 17. So your answer would have been 3 times the square root of 17, correct? Should have been 3 times the square root of 27, which means we can't stop there.
3 and 9.
Yeah, factor that into a 3 and a 9, where we're going to take the square root of the 9 to get another, 3 out here, which ends up giving us times the square root of the 3 there. Did anyone have a faster way that maybe you did it? Besides starting with 9 and 27, Aubrey? Yeah, if you try, well, I can't cut it in half because it's an odd number, right? But if I cut it in thirds, 81 times 3 will get me here right away. So bigger numbers, I like try to cut them in half, cut them in thirds. That doesn't work. Maybe cut them in fifths, especially if you see the 5. How many ended up with that answer, though? 9 times the square root of 3, regardless of how you approached it. Anyone end up leaving it at 3 square root of 27? Obviously, he did because he had division here. Just had to leave it at 17. All right, makes sense. Go a little bit further if you can. Number 38, it's all letters. And when it comes to letters, remember, when you take the root of powers, class, you divide the exponent by the index. Again, everybody, this time to take the root of the power, divide the exponent by the index. What do we do, Glenn?
Divide the exponent by the index.
There we go, divide the exponent by the index. So on number 38, remember division is really asking this question. How many times does this go into that? So on number 38, Danielle, we're really asking ourselves, how many times does 5, the index, go into the exponents of 5, 6, and 12 respectively. What did you get for your answer?
Well, I messed it up.
So what should we have done for our problem then?
You should have, because it comes out to 1 for that, and then for B it comes out to 1 with 1 left over, and then for C it's 2 with 2 left over.
There we go. 5 goes into 5 once with no A's left. 5 goes into 6 once with 1 left. 5 goes into 12 twice with 2 left. Again, do we have to write the 1s here, class? No, so we could take them off if we wanted to. There's not a problem leaving them. So since I'm lazy, I normally wouldn't go back and erase if I'd taken the time to write them in the first place. How many have that answer for number 38? All right, questions on that one? Make sense now?
Yeah, I just got lost because I was like, oh wait, what do I do inside the house? But yeah, I know it.
All right, taking a look at the next one. We have the cube root of 9d to the 7. Evie, if this were a square root of 9, that's awesome because I know the square root of 9 is 3. But it's a cube root of 9. So the fact that 9 is a square does me no good. I've got to find one of these numbers inside a 9 as a factor of 9, but none of them, right? So the 9 just stays because you can't do anything with it. You can't factor it, you can't take the root, leave it. But as far as the d to the 7th, I can do a little bit.
D squared.
Pull a d squared out because 3 goes into 7 twice with 1 left over. So we'll leave a d inside, we get d squared times the cube root of 9d. How many have that answer for number 40? 40 questions on number 40. Number 42, we had the 4th root of 48. Now, Glenn, I've got a nice little list here of squares. We memorized these in elementary school, right? Cubes, Hayden's memorized at least, right? And we could figure it out, right? If we needed to make this list for ourselves, 2 cubed, figured out 3 cubed, figured out 4 cubes, takes a little longer to figure out, but still not bad. 5 cubed. Okay, this is fourths. So we need a 4th. So we don't have a lot of them, but 2 to the 4th is 16. Is there a 16 in 48? There is, yeah. If that hadn't worked, maybe we tried 3 to the 4th, but what's 3 to the 4th, anybody?
81.
That's 81. Okay, so we definitely know an 81 doesn't go in a 48. 16 does, so we could factor this into the 4th root of 16 times 3. We'll take the 4th root of the 16, 2, and we'll leave the 4th root of 3, right? So we'll factor it into a 4th, not a square or a cube, but a 4th, 16 and 3. Take the 4th root of 16, which is a 2, and then leave the 4th root of 3. How many got that answer? That was a harder one. Okay, a couple of you did. Those who didn't, does it make sense now?
For some reason I got a 6.
For some reason I got a 5.
Wow.
Inside
a 5?
the thingy. Inside the thingy. Like inside the thing.
So you did 8 and 6. I think you were thinking cube then, because the cube root of 8 would give you a 2. But again, this is a 4th root, so 8 doesn't help me at all, right?
I think my brain shut off for a second. I did 3 plus 2.
Oh, interesting. All right. Let's move on to number 44. And Lexi, the square root of 44, how did you factor it?
4 times 11
And so your answer?
is 2 to the square root of 11.
2 times the square root of 11. How many had that for number 44? The last one a little bit easier. All right, questions on those evens? Other than maybe 4th root of, well, let's just ask it this way. Was anyone perfect? Like I felt like you were.
I just, the 36, I just put the number wrong.
Okay, all right. Anyone just missed 1? Because I know a lot of us missed that 4th root of 48. Okay, good. Anyone just missed 2? All right, are there questions on the 1 or 2 we missed, or did we take care of them by showing them on the board? Feel like we got it now? Go back into the odds now, 35 to 45, the odd. 35 to 45, the odd numbered problems. Lexi's finished. You're not finished.
No, I did it for homework.
Oh, you did it for
I-
homework.
yeah, I
Oh,
did it
you
for
cheated. Oh, okay. Okay, I've been done. I don't know what's taking them so long. Aubrey's finished. Did you cheat too? You were just having so much fun reducing radicals, you couldn't help yourself. You had to do the evens. Is that what it was? Yeah. Hayden finished? Thinking.
Oh, this whole time I was thinking that 245, but it's square, not cube. That makes more sense. I just didn't look until now.
Remember I said there's one number that's kind of weird. And if you're having a hard time figuring out a number, there's one that just kind of, it doesn't pop up very often, but it's just kind of weird in there. Or if it's a big number, remember, try cutting it in half. If that doesn't work, try cutting it in thirds. If that doesn't work, try cutting it in fifths. And maybe that would work.
Now you tell me.
Oh, I've said that before. In fact, I said it earlier this hour, I believe. Go back and watch the tape. Now Hayden's finished.
Who's John?
You're coming.
I know it's like 810, but like, isn't a 9 going in there?
Sure.
Not okay, sure. Does it matter?
just a little bit longer to be working on these, and then we'll take a look at them together.
We should have a nap time at the school.
Nap time before you came. All right, let's take a look. Number 35, the square root of a to the 9th. What did you get for your answer, Lexi?
A times a is 4. I think that's what this is.
Glenn? A to the 4th times the square root of a. So remembering that the index is a 2, 2 goes into 9 4 times with just the 1 left over. Is this what you had? You flipped it. You pulled the a out and left the a to the 4th. So yes, 2 goes in 4 times with 1 left over, so leave the 1 inside. Let's stay with Lexi for redemption on number 37. I would love to do 5 times 100, but it's not a square root. So 100 doesn't do me any good at all. How did you factor the 500, Lexi?
I don't remember how I factored it. I have the answer though.
Without the factoring?
I mean, I have the factoring, but it's like really messy.
Oh, okay. What was your answer, Lexi?
5 times the third root of 4.
Good. So Lexi must have then factored her 500 into 125 times 4, which again, the only one of these that looks appealing at all for a 500 would be the 125. It does work. Took the cube root of the 125 to get 5. Left the cube root of 4. Excellent. Number 39. Evie, we've got the square root of a 245x. For now, we're going to focus on the 245. How would we factor that up? 49 times 5. So we'll take the square root of the 49. We'll leave the square root of the. And then when it comes to the x, exponent 1, index 2, can 2 go into 1? So what do? Leave it as well. So we end up with 7 times the square root of 5x. Number 41. Wow, another big one. We have the square root of 605. Again, with big numbers, Danielle, the strategy is try cutting the number in
Half.
Or if that doesn't work,
Fifths.
half, thirds, and fifths. We wouldn't want fourths because 4 is a square. But yeah, how did you end up factoring this?
I did 13 and 5.
13 and 5.
50?
Okay, Danielle.
Well, I looked at it wrong.
5 goes into 60 how many times?
12.
12. Nothing left. How many times 5 go to 5?
1.
So 121
the
times
one.
5.
I added the
Oh,
one.
gotcha.
Sorry.
Okay, so should have factored into a square root of 121 times 5. So should have had
11 is this times the square root of 5.
11 times the square root of 5. And that's the only way you could factor it. There's not a smaller square. So if you were trying the conventional way, does 4 go in? Nope. Does 9 go in? Nope. Does 16 go in? Nope. Does 25 go in? Nope. 36? Nope. 49? Nope. 64? Nope. 81? Nope. 100? Nope. 121? Yep. But that takes forever. Big numbers, just cut them in half. Well, it doesn't cut it in half. Cut it in thirds, can't cut it in thirds. Fifths?
Trying to do the 49, because you said the 49. But
Well, that's if the 2, 3 cutting in half, thirds, and fifths method ain't working. And, 49 doesn't go in there, does it? Yeah, it's very rare. That's why that's the weird one. If nothing else seems to be working, try the 49. But try second cutting halves, thirds, and fifths first. Number 43, it should be screaming at you, Hayden, the square to factor.
81.
81. It's right there in front of your face times 10, obviously. So we end up with
9 times the square root of 10.
9 times the square root of 10. Now you could have done 9 times 90 and gotten 3 times the square root of 90. But then you can see we can still factor that into another 9 times 10. Get another 3 times the square root of 10. That gives us the 9 times the square root of 10. How many ended up at that point regardless? Anyone leave a 3 times the square root of 90? Good. So we took it all the way down. And then number 45 is the square root of 18x. And Aubrey, square root of 18? 9 times 2, take the square root of the 9. 3, and then leave the square root of the. And then what about the x? Leave it in the radicand, right? Leave it there inside the radical as the root. So 3 times the square root of 2x. Anyone perfect on 35 to 45, the odds? Okay, few of you this time. Anyone just missed 1? Okay, so we did have the 1 wrong. Okay, anyone just missed 1? Besides Lexi? Just missed 2?
I just
Do we understand the couple that we missed? Any questions? Flip over to page 515 then, page 515. And there in the chapter 11, review A, go ahead and do numbers 1 through 10. Numbers 1 through 10 in the chapter 11, review A. One through 10. 1 through 10 in the chapter 11 review A.
I don't know what number 4 is. That's confusing.
Think about it. You don't think good. Then move on and come back to it so you don't waste time, right?
It's like right in this page.
Did you write all those?
What?
Did you write all those?
Mm-hmm.
Usually Genesis 4.
I have to, yeah. I'm going to see it though when she sets it up on Monday.
Like the way she drew all the stuff, it's crazy. It looks really good.
I bet. She's got an artistic flair, so I'm sure she would great. Do you have an artistic flair on your board?
No, mine's just this colored paper with the paper stuff on it.
It looks neat at least.
Well,
That was my method. Like, I'm not artistic either, so mine was neat. It just wasn't
Yeah.
fancy. It was just.
Mine's written.
It has
with
all
like
the
the words and
words.
colored pens.
Yeah,
Not
mine's
Sharpies.
separated in black sharp.
Are we done with 1 through 10 yet?
Yeah.
Most of us are.
It's the blue.
Oh, I saw it.
They're coming for you.
There's ghost saucer in this one.
Further?
Are they not in the park?
It's an
I don't
ambulance.
doubt it.
I saw it.
That's where, Nicholas. That's my mom's best friend's baby dad.
Nicholas Coon.
Right. Number 1. What's the name for a number written inside a radical symbol, class? A radicand. Good, Evie. What's the name for the small number that indicates which root is to be taken, class? Index. There we go. What is understood to be the index when an index is not written?
Squares.
A 2, right? Which means a square root, but the number itself is a 2. And what's the name for any number whose square root is a whole number, or you could say an integer?
Perfect square.
A perfect square. A perfect square. Well, the solution is rational, it's true, but we call it a perfect square. So 4 is a perfect square, 9 is a perfect square. They work out rationally, but we call them perfect squares. Number 5, what is the square root of 16, class? 4. Number 6, the square root of what would be 0? 0. Square root of 1 isn't 0, it's 1. Square root of 68 or 64 is 8. What would you have to take the square root of number 8 to get a y? Y squared. You'd have to take the cube root of what to get a 7?
343.
343. And then the cube root of x cubed is just x. Questions on that? Remember fractional exponents? Take the exponent, divide it by the index using a fraction bar, and then you can simplify. Do that on 11 through 22. Do 11 through 22 very quickly. Write as fractional exponents and then simplify. By the way, do fractional exponents always simplify? Not always, no. But if you could simplify, do so. I think most of them do. Exponent over index.
I think I've memorized 15 times 15 before.
If not, you can always do it over. Tissue. All right, for sake of time, put your pencils down. Let's take a look at these together. Number 11, how would I write that using a fractional exponent? Lexi?
5 to the 2 over 2.
Well, 15 to the 2 halves. And, of course, that just becomes 15. Number 12, how would I write that initially, Glenn? Well, that's the final answer. How do I write it initially? U to the 12 thirds, which becomes, as you said, U to the 4th. Number 13, initially, Evie? 6 to the 70 35ths, which becomes 6 squared, which is 36 for our final answer. Number 14, initially we'll write that, Danielle, as?
R to the 12 over second.
Well, good, R to the 12 halves, 12 tooths. R to the 12 halves, and that becomes?
R to the 6th.
R to the 6th power. Number 15, initially, Hayden?
K to the 72 ninths.
K to the 72 ninths, which becomes?
K to the 8th.
K to the 8th. Number 16, initially, Aubrey? 26 halves. Good, B to the 26 halves, that becomes? B to the 13th. For number 17, initially 2 to the 42 sevenths, that becomes, Lexi, 2 to the 6th, which is?
I forgot to put that.
Anyone?
64.
64, good. For the next one, number 18, initially 3 to the 4 fourths, but Glenn, that's just 3 to the first or 3. Number 19, 5 to the 12 fourths, class becomes 5 cubed, which is 125. Number 20, initially V to the 8 fourths, of course that becomes, Danielle?
V squared.
V squared. Number 21, initially 8 to the 15 fifths becomes class 8 cubed, which is 512. And then number 22, 21 to the 9 ninths, which of course is just 21. Questions on that? Remember, in order to multiply radicals together, you gotta have the same index. To multiply them, the indexes have to match. 23 through 25, take just a moment, yes or no, can you multiply them? Then if you can, go ahead and do it. Take just about a minute, if that, to do 23 through 25. Hayden says, I don't need a minute. And Hayden, 23, can you multiply? No. Radicands match, but that doesn't matter. The indexes have to match, and they don't, so you can't multiply. Number 24, can you multiply those, Hayden? Yes, you can, and you get?
The cube root of 30.
Cube root of 30. Number 25, can you multiply those, Aubrey? Yes, you can, you get? The fourth root of 5a cubed b is correct. How many got all those correct? 23, 24, 25. Any questions on that? All right, turn the page. Back to reducing radicals. Now again, if you can take the root evenly, you do it. If you don't have to factor, don't. If you're given the square root of 81, don't split that up. Just take the square root of 81 and get 9. But if they give you the square root of 80, well, you can't take that. So that's where you'd have to split it up. I want you to do just 26 to 34 for now. 26 to 34 there on page 516. Oh, 26 to 34. Oh,
And my list of numbers.
write it down on the side.
Okay.
If you need to write yourself a little list across the top of the page, not a bad idea. That way you can see them right there in front of you. Good idea on quizzes and tests to do the same thing. Hayden's finished. Evan's finished. I can see these things. Glenn is thinking. Yes, is thinking.
Confused what to do with like 169 because you can't do 2, you can't do 3, you can't divide it in half, you can't.
You're right.
You can't do anything.
You're right. Except
Except what?
it's 169 doing that.
Oh, is it a square? What's the, which one?
We'll figure it out. It's obviously bigger
Are
than
you
12
kidding me?
squared.
I sat here all this. It's a number. I'm not telling you.
It's a 17.
Look it up.
16.
You got it in your book. Look it up.
It literally is on page 5 or 6. Oh my
Numbers
goodness.
written down, look at the numbers. Look at the numbers
It's
that
13. It's 13. This is depressing.
I don't like roots.
Serious.
But Evie was smart and she did all the other ones.
I know, that's what I started
And
doing
came back to
until
that
you
one.
said a perfect square. Until you said a perfect square.
You weren't here.
Evie,
He wasn't here.
it's okay. Face the front.
I was here.
You'll be fine.
See, one of them was one, the other was problem.
It's okay. Just look. It's the fun. I know you want to help Glenn.
Needs lots of help.
Poor little son.
Thank you.
But Glenn's feet aren't down, so you can't help. Still. Take just another minute or so.
Is 189 a perfect square? No.
So we factor it.
Something downstairs first.
Gosh, figure it out for yourself. You can't help her on a quiz. Don't help her now. People get dependent on help. I know, but people get dependent on help, right? As if you start helping them now, when they get to the quiz, they feel lost. It's like people in society, and they've looked to the government for help, and now they're just kind of lost,
Now they
and they're stuck on help, and they can't get out of it. That's why we don't have people working. It takes forever to get fast food. Anyway, let's go ahead and get off politics and back to this. Number 26, super easy. What did you get for the square root of x to the fourth y to the sixth, Hayden?
X squared y to the sixth.
Oh, Aubrey.
Y cubed.
X squared y cubed is correct. For number 27, if you remember that 169 is one of our squares, it's also a really easy problem, Aubrey. 13m to the fourth. If you forgot that 169 was a square, you're stuck because there's no way to split that up. It is itself a square. For number 28, easy to take that fourth root, Danielle.
A squared b.
A squared b. Number 29, also pretty easy, especially if you remember 125 is one of our cubes, which we should. We've seen it up there on the board often enough, Evie.
5d cubed. R squared.
5d squared is correct. Number 30 is probably one we want to factor, but the factors should be screaming at you. Glenn, how should we split up an 81 or an 8,100? 81 times 100, and we can take the square root of 81 and the square root of 100, so we get a nice easy integer answer. 90 for our final answer. Number 31 doesn't work out quite as nicely, but it's still not hard to factor up. How do we factor 31? Lexi?
25
Times 7. So our answer is?
20, it's supposed to be 5 to the square, times square root of 7.
5 times the square root of 7 is correct. Number 32, not hard to factor. Hayden? 4 and 6, so our answer? 2 times the square root of 6. Number 33, not bad to factor. The answer is not quite as pretty as we'd like it to be. We still have a fairly sizable radicand here, but how did you factor it, Aubrey? Didn't do that. Well, what factors should we see in a 189? We have 4, 9, 16, 25, 36, 49, 64, 81, 100. Well, if all else fails, narrow it down to the big 4. 100? Nope, doesn't end in double zero. 25? Nope, doesn't end in 25, 50, or 75. So that either leaves 4 or 9, but it's not an even number. So it's got to be... Right, so here's the tendency we have, right, is to be like, I don't know, and we stare at it for a while. Don't. If you can't see one of these quickly, run through your big 4 and narrow it down. It's got to be 9, surely. If that didn't work, try cutting in half or thirds or something. But it does work out with the 9 times 21, and so we end up with 3 times the square root of 21. Or, like I say, if you try cutting it in half, that won't work. Thirds, 63. I suppose if you did that, you're like, well, neither of those is a square, but maybe now you see the 9 a little bit more easily, right? And get the 3 from that, and then leave the 3 and the 7 inside. You could take that approach. I think this is the better approach there, seeing the 9. And then for the square root of 225n, not bad if you remember 225 is a square, class. 15, but the n isn't, so... 15 times the square root of n. We take the square root of 225 to get 15. Can't do nothing else with the n. Leave the square root of n, and there's our answer. Anyone perfect on the ones you did? Even if you didn't finish them all, the ones you did, you got them all? Anyone just missed one of the ones you did? Questions on any of these? Or do we feel like we understand them better now? Finish out the section, 35 to 43. Finish out the section then, 35 to 43. for sake of time, pencils down. Let's take a look at these answers here. What did you get for number 35? Evie?
X cubed, or x squared times the square root of 15.
Can't do anything with the 15, but you can take the square root of x to the 4th. Great job. X squared times the square root of 15. Number 36, Danielle.
Y squared times the square root of y.
How many times does 2 go into 3?
1.
Only once, with 1 left over. So y times the square root of y. For redemption, Danielle, number 37.
3 times the square root of 8.
Not a wrong answer, but not finished reducing, because you can still factor into...
2. Like, get 2 3s. So 2.
How do you factor an 8, Danielle?
2 cubed.
No, how do you factor an 8, Danielle?
Divide 2.
With one of those numbers.
4.
4 times
2.
2. There we go. And then you take the square root of the
4.
times the 3 gives us...
6 to the square root of 2.
There we go. That's the complete answer we want there. So remember, we're not looking to prime factor necessarily. We're looking to get one of our key numbers. 6 times the square root of 2 should have been our answer there. Number 38, moving on. Let's go to Lexi. What did you get?
X squared y times the square root of x squared y.
Really close. Only one thing, class. Cube root. Yeah, x squared y times the cube root of x squared y. Don't forget to keep that index intact. Number 39, what did you get for your answer, Hayden?
31.
Couldn't figure that one out. Glenn, did you figure it out? What was your answer?
6 times the square root of 6.
Yeah, the 216 ends up factoring into a 36 times 6. And so we end up getting a 6 times the square root of 6. Or, Hayden, for a 216, add up the digits. You should see a 9 in there. You could have factored into 9 times 24 to get 3 times the square root of 24. And then further factoring and taking a root would get us to the 6 times the square root of 6. So we should have at least seen the 9. For redemption, Hayden, number 40.
I was confused.
What do we get if we have to write it as a fractional exponent?
3 over 9.
1 to the 3/9, which you could say is 1 to the 1/3, I suppose. But here's the thing. No matter what power you raise it to, 1 to any power is always 1. So there we go for number 40. That was tricky. Number 41, not as tricky. What did you get for your answer, 41? Back to Hayden.
3 times the square root of 6.
Cube root of 6? Don't forget, don't lose that index. 3 times the cube root of 6 is correct. You'll factor that into a 27 times 6. Stay with me. Number 42. What did you get for your answer, Aubrey?
6
Good. In a perfect world, you see the 3 times 36. In a more likely world, you see 9 times 12, and then the 12 further factors into 4 times 3. Good job with the A as well. 6a squared times the square root of 3a. And then finally, number 43 works out evenly, class. 5d squared is correct. Good. All right, homework for this evening is to finish up the page by doing the homework 1 through 15. Page 516, do the homework, numbers 1 through 15, and we're going to take a quiz over this in our next lesson. All right, have a wonderful rest of your day, and you are dismissed.